Hi everyone, and I hope you guys are doing fine. Hope you had a good weekend. We are gonna go ahead and take a look at the rest of the notes from 2.3 that the video didn't cover. There's parts of example 3 that weren't covered, and then the video kind of just cuts off right in the middle of one of the last examples, and so I'm gonna recap that and then finish out that example for you and the rest of the notes. So make sure, even if you haven't watched the first video yet, make sure you open your lesson to lesson 2.3 and fill these parts in so that you will have completed notes whenever you do watch the rest of the video. So in this lesson we have been talking about conditional statements of the form if blank, then blank. And so we use those, instead of just saying blank for both of those, we use letters like P and Q to identify the two terms hypothesis and conclusion. And then we evaluate the truth value based on the fact that in order for a conditional statement to be true, the hypothesis must be true and the conclusion needs to be true, or the hypothesis can actually be false. And we'll talk about that more and more as we go through this lesson. So let's take a look at this example 3, part C. We want to determine the truth value of the given conditional statement. If it is true, we want to explain our reasoning, meaning explain why we're saying it's true. And if it's false, we want to be able to give a counterexample. Again, the only way to prove that this statement is false is if the hypothesis is true and the conclusion is false. You'll remember that the hypothesis is the part of the sentence that follows the word if or when. So our sentence read like this: if yesterday was Tuesday, then today is Monday. That's our statement. And so we want to look at these as hypothesis and conclusion. So hypothesis is yesterday was Tuesday. The conclusion is the part of the sentence following the word then. Today is Monday. When we identify hypothesis and conclusion, notice I'm not underlining the words if and then. Those are parts of your statement that are not part of the hypothesis and conclusion. We don't need those. So we want to figure out the truth value. And again, in order for a truth value to be false, the hypothesis must be true and the conclusion must be false in order to say that the overall truth value is false. So let's look at this. If yesterday was Tuesday, then today is Monday. So let's think about this. If yesterday was Tuesday, so you're watching this, today is actually Monday, so this is a false statement. Then today is Monday. Today is actually Monday. But since our hypothesis was actually false, there's no way to verify that today is in fact not Monday. So we assume that the overall statement is true. But if we were watching this on a day when yesterday was Tuesday, so if we were watching this video, or if you do watch this video and it happens to be the next day after Tuesday, which would be Wednesday, then this would be a false statement. But because we cannot verify it, we assume that it is true. Okay, the next part, we're going to do the same thing. We want to determine the truth value of the conditional statement. If it's true, we want to explain our reasoning. If it's false, give a counterexample. So, when a rectangle has an obtuse angle, it is a parallelogram. When, or we could also replace that with the word if. So that is the part that becomes our hypothesis. Okay, and our conclusion is that it is a parallelogram. All right, so let's identify truth value here. A rectangle has an obtuse angle, so is that true or false? Well, you might remember on a previous example we looked at when a rectangle is made. Because it's a rectangle, we know they're all right angles, so a rectangle cannot have an obtuse angle, so that statement is false. Then it is a parallelogram. Well, whether that's true or false doesn't really matter since the hypothesis is a false statement. And remember, since the hypothesis is false, we cannot verify the conclusion to be true or false because we haven't met that condition. There is no rectangle that has an obtuse angle, so we assume that the overall statement is true. And our reasoning is because since the hypothesis is false. Anytime the hypothesis is false, we assume the overall statement is true. All right, then we moved on to example 4, where you guys had already started to write out the conditional statements of converse, inverse, and contrapositive for this, and so it looks a little bit like this. All right. We have our converse, inverse, and then contrapositive of the conditional statement, and so you should have all these written. The video in the first part of the lesson does get all these written down, and then we start to talk about truth value. So the original conditional is this: if an animal is a bat, then it can fly. Well, we have animals that are bats, so that could be true, and bats do fly, so that is also true. The conditional then is true. We don't need a counterexample. The converse of that statement, if it can fly, so if we have animals that can fly, then an animal is a bat. Here's how I know this is actually false, because I can have a flying animal that is not a bat. A flying animal that's not a bat would be a bluebird. There's your counterexample. That's not a bat. Okay, the inverse statement. If an animal is not a bat, then it cannot fly. Once again, I can think of an animal that is not a bat that actually does fly. Again, bluebird works for the same counterexample. Any other flying animal that's not a bat would work. And then the contrapositive, and this is where it gets a little confusing because you're kind of talking in double negatives. If it cannot fly, then an animal is not a bat. Well, if I have an animal that cannot fly, then it cannot be a bat because bats do fly. So this is actually true. And here's what we want to do. Once we've said these, we want to make sure that our logically equivalent statements match up. Remember, conditional and contrapositive, the original and then the very last one you've written, are always logically equivalent. And these middle two, converse and inverse, the ones that have the word verse, those are also logically equivalent, which means they should have the same truth values. And they do. So these are both false in the middle, and then the first and last are both true. Okay, these are called related conditionals, and they are logically equivalent. All right, here's what I want you to do to finish this up. You've got one more example, and I want you to write the conditional originally, the converse, the inverse, and the contrapositive of the following statement. The sum of the measures of two complementary angles is 90. We want to write that as a conditional statement, and then I want you to write the converse, where you switch the hypothesis and conclusion, the inverse, where you keep the order the same but negate the hypothesis and conclusion, and the contrapositive, which is the fourth one, where you will flip the order and negate both parts of that statement. So I'm going to help you by writing the conditional for you. You guys might be able to do that part on your own, but this is how I want you to write the conditional statement. If two angles are complementary, then the sum of their measures is 90 degrees. That is your conditional statement. The hypothesis is that two angles are complementary. The conclusion is that the sum of their measures is 90 degrees. I want you to write the converse, the inverse, and the contrapositive. So if you would have the substitute pause the video now, then when everyone has that done, they will push play and you will check your answers. All right, if you haven't paused the video yet, go ahead and do so now. Otherwise, these are the answers we should get. The converse is, if the sum of their measures is 90 degrees, then two angles are complementary. The inverse, if two angles are not complementary, then the sum of their measures is not 90. And the contrapositive, if the sum of their measures is not 90 degrees, then two angles are not complementary. All right, and to evaluate truth value, we're just going to look at the original conditional statement first. If two angles are complementary, so think of two angles that are in fact complementary, then the sum of their measures is 90 degrees. That is a true statement. So the original conditional is true, which means The logically equivalent statement, if you've written it correctly, should also be true. The contrapositive will be true. If the sum of their measures is not 90, then they cannot be complementary. The middle statement, the converse. If the sum of their measures is 90, then the two angles are complementary, and that is also true. And since it's logically equivalent to the inverse, that is also a true statement. If two angles are not complementary, then the sum of their measures is not 90 degrees. All right, that wraps up our lesson for 2-3. It took a little bit of extra time. Hopefully you can understand that better by watching these videos. Remember that you've got the rest of class time to work on this assignment for 2-3. The truth value evaluation for these statements can be kind of tricky. I understand that. If you have any more questions, come in tomorrow and we will talk about it again at the beginning of class and try and clear that up for you so that it's easier to understand. But otherwise, once you are done with the 2-3 assignment, make sure you grade it using the keys that I post on the Edmodo page. And then also make sure you get ready to do the next assignment, which is lesson 2-6. Now we're going to take our notes and go out of order for that. The next video that is posted tonight will be over lesson 2-6, algebraic proof. Make sure you skip lesson 5. We'll come back to that next time. All right, again, if you have any questions, you can see me in class when I show up again. Thank you and have a wonderful day.